All of the nutrients that our body needs are obtained from plants. Whether we get them indirectly from animals or directly from plants, these nutrients are necessary for life. One of the most vital chemicals in biology is nitrogen. Nitrogen is a component of amino acids in proteins, the nucleic acids in DNA, and chlorophyll in plants. With this in mind, one might think it's really important for plants to be able to get nitrogen. So, how do plants do it? The answer is more complex than you may think. Although nitrogen gas makes up the highest percentage in our atmosphere, plants cannot contain nitrogen directly from the air. Rather, they must absorb compounds that contain nitrogen from the soil. With chemicals like these in the soil, you can be sure that your plants are flourishing. If you're looking for a way to increase the nitrogen levels in your crops, we recommend our newest fertilizer that will alter the carbon, nitrogen, and phosphorus ratios in your soil. With our product, your land will reach its maximum productivity. You'll find that our product will increase crop yield and quality within the first harvest. We attribute our success to the many tests conducted for looking for the perfect ratio of elements in the soil. We believe our product has achieved the best ratio possible and will increase the nitrates in your soil. The method we use is called the Haber process and produces the basic building blocks for nitrogen fertilizers, ammonia.
The Haber process was developed by German chemist Fritz Haber around 1900. He devised a way to convert nitrogen gas into a useful product, ammonia, using hydrogen gas, heat, and pressure. Haber wanted to make nitrates for use in explosives during World War I. This would mean that Germany would not have to rely on foreign sources to obtain nitrates. Although his motive for creating ammonia was more focused on explosives than plants, we can still thank him for his contributions to modern agriculture. The chemical equation representing the conversion of nitrogen and hydrogen to ammonia is N2 plus 3H2 yields 2NH3. With this information, we can calculate how much nitrogen gas and hydrogen gas we need to create enough ammonia for use in industrial fertilizers. This can be done with the help of stoichiometry, an essential math skill for chemists in every field. Stoichiometry is used to measure the inputs and outputs of chemicals and chemical reactions. It is most useful for converting grams of one substance into grams of another substance, though that is not the only way it can be used. Here is how a usual stoichiometry problem would be completed. Say you have 31.76 grams of water that decomposes into hydrogen and oxygen. How many grams of oxygen would we obtain from this? The first step is to set up the chemical equation for the process described. This process's equation is 2H2O yields 2H2 plus O2. The second step is to multiply the number of grams of water that decomposes by the number of grams of water in 1 mole of water. This ratio is 18.02 grams of water per mole of water. The third step is to multiply the new number by the molar ratio of O2 to H2 on the equation. The moles of oxygen are in the numerator and the moles of water are in the denominator. The molar ratio of oxygen to water here is 1 mole of oxygen per 2 moles of H2O. The final step is to multiply this new number by the grams of oxygen per 1 mole of oxygen. The grams of oxygen are in the numerator, and 1 mole of oxygen is in the denominator. This ratio is 3.00 grams of oxygen per 1 mole of oxygen. When we multiply and divide all of these numbers, we get that when 31.76 grams of water decompose, 28.02 grams of oxygen are produced. Now that we have demonstrated how to solve one of these problems, let's apply our newfound knowledge to a real-world situation. A company which produces nitrogen fertilizer needs 5.27 times 10 to the 10th grams of ammonia to make more nitrogen-based compounds. How many grams of nitrogen and hydrogen will be needed to produce this amount of ammonia? We already know that the chemical equation for the Haber process is N2 plus 3H3, or H2, yields 2NH3. We will need to split this problem into two parts, figuring out how much nitrogen we need and determining how much hydrogen we need. For both of the equations, we will multiply the 5.27 times 10 to the 10th grams of ammonia by 1 mole of ammonia over 17.04 grams of ammonia. To obtain the necessary amount of nitrogen, we then multiply the number we received by 1 mole of N2 over 2 moles of NH3. Finally, we multiply that new number by 28.02 grams of N2 over 1 mole of N2. And then we determine that we will need 4.33 times 10 to the 10th grams of nitrogen. To obtain the necessary amount of hydrogen, we multiply the number of moles of NH3 we received, so that is this part of the equation, by 3 moles of H2 over 2 moles of NH3. Finally, we multiply that number by 2.02 grams of H2 over 1 mole of H2. We then receive that we will need 9.37 times 10 to the 9th grams of hydrogen in order to produce 5.27 times 10 to the 10th grams of ammonia. So, we will need 4.33 times 10 to the 10th grams of nitrogen and 9.37 times 10 to the 9th grams of hydrogen. With stoichiometry, we can make sure that our fertilizer has the perfect amount of nitrates in order to nourish your crops.